I think we are ready to begin. Thank you, everyone. My name is Sundar Raghavan. I run the RDS business. RDS stands for Relational Database as Service. This afternoon, I know you have all graciously agreed to share about 55 minutes of your time. So we'll make it very productive and very useful. In terms of logistics, if I could request those of you who have loud cell phone ringers, either put it in vibrate or turn it off if you could. I would appreciate that very much. Conversation-wise, we'll get the initial dialogue going, and then towards the end of the conversation, maybe around 10, 15 minutes, we'll be able to do Q&A. So hold your questions. When you are prepared to ask questions, please come up to the mic. I think there is one here. If you cannot, then I'll repeat the question so that everyone can hear it properly. I'm honored to be joined with two of my proud customers, Zac-Sprackett from Sugar CRM. He'll come after my initial remarks. And then Michael Thomas, Principal Software Engineer from Scopely. So those two gentlemen have a fantastic story to tell. More than what I say, I think what they have to share is probably more important, so we'll save most of the time for them. Here's roughly what we're going to cover. First, we're going to talk about various database options that are available for you on AWS. I know many of you are building pretty sophisticated, interesting internet, mobile, social, enterprise applications, and there are always a set of questions that you have, and these are questions that we have often heard from customers. So we'll share with you what we have heard from customers, how to think about them, or how they have thought about them. We'll also hear from two customer case studies, Sugar CRM and Scopely, on how they thought about those questions and how they answered it for their customers. First, one of the core Amazon principles is to start with the customer and work backwards. You heard that from Andy Jassy. You would have heard that from Jeff. So I thought I would start with a few questions. Let's ask the simplest question. How many of you use databases on AWS? That's a pretty good pile. That's a really nice count. So thank you. And those of you who didn't raise your hand, hopefully our talk will help you actually use databases on the cloud. How many of you have heard of RDS or used RDS, DynamoDB, Redshift, or Elasticache, any combination? Again, less than what I would like, so but we'll try to get that going. How many of you have a well-defined DR strategy? By DR, I mean disaster recovery. I know. Those of you who raised your hand, congratulations. You are among the elite. Those of you who did not, now would be a good time to start thinking about disaster recovery. Not that our infrastructure is not resilient. It is designed to be very resilient. But as we all know, stranger things have happened. So I think it's important to think about it. We have been thinking about this problem for our customers. In this conference, you will hear a couple of announcements, particularly those of you who have not started with a DR plan. I'd encourage you to attend Werner's keynote tomorrow, where we are going to be making a couple of announcements that will make your overall disaster recovery story. I'll share some of it here, but more interesting news to come tomorrow. The other question I had in mind, from an applications perspective, we have seen a lot of customers start building geospatial and location-aware and context-aware applications. So question-wise, question to the audience by show of hands, how many of you are building geospatial or location-aware application? It's about 10, 15% of it. As they say, good news comes to those who wait. So tomorrow, if you wait for one more day, you will see a pretty interesting announcement that will make your life easy and exciting to build geospatial applications. All of that is coming up in Werner's keynote tomorrow, so I encourage you to go to that one. With that stated, first thing I wanted to say in the context of disaster recovery, one of the key features that we recently announced, and we'll be making more announcements, is this idea of cross-region snapshot copy. So you can do it in a few ways. First of all, if you're using EBS or S3, in addition to running your own databases, you can do cross-region snapshot copy, cross-region backup copy using S3 and EBS APIs. About a couple of weeks ago, we announced RDS snapshot copy. What that means is every night or every 4 hours, every 8 hours, you can make a backup of your entire database and have it be available in a region completely different from the one you are operating on. This is not about multiple availability zones. This is about actually going across regions. So you can go from East Coast, Washington to Oregon PDX, or from Brazil to PDX, and so on and so forth. This gives you an additional layer of protection where you are only paying a small amount of storage and network transfer charges, but you have your entire database backed up and available in a different location that you can, at a moment's notice, spin up a new database. This we call as democratizing disaster recovery. Typically, if you have had to do that without the cloud, you would have had to find 2 colo providers, network interconnects, and have a strategy behind how you are going to copy and how you're going to spin up. Literally, this is a one-button operation for a fraction of the price. We have had a couple of customers test drive it. Zoopla, who are very similar to real estate location services that we have here in the US, they've used it and they have had pretty good success with it. Prior to this, they used, their disaster recovery used to take 3 days. Pretty much every week, they would be spending a couple of days doing copy and move and other things. Now it's just a few steps, and they are a happy user of it. So I would encourage you to think about it, test drive it. Now, thinking about your core mission, one of the things we hear from our customers is their core mission is to build an app. So whether it's 0 to app in 10 minutes, 15 minutes, 100 minutes, 1,000 minutes, that's all up to you. 0 to millions of users is, again, core part of your mission, and that's how well it's designed and how well you can scale. And these are areas where AWS can help. We can give you infrastructure that scales virtually unlimited fashion. We can give you app building capabilities that lets you unleash your creativity. Becoming a 0 to hero or 0 to an IPO in a few months, that's totally up to you. So we give you the tools, and you can get going on this. At the end of the day, all of this, to us, when the database questions comes up, we think about is it's not about the database per se, it's about actually your app. What are you trying to do with your app? That's what the key question that we try to help our customers think through. Most applications look like this. Typically a load balancer or some form of scale factor right in front of the application. Then you have an application tier or a web tier that talks to your database tier. What starts out to be a stack becomes a stack of worries pretty soon. So initially at the load balancer level, you think about security, scale, and availability. Then at the app tier level or the web tier level, you think about security, innovation, scale, performance, and availability. As you move down the stack, you end up thinking about security, innovation, scale, transactions, performance, durability, availability, backup, and do I have the right skills? This is what slows down a lot of the innovation. What we try to provide through the database service choices that we provide on AWS is to help you focus on the parts that you can do really well. There are also choices that we often hear from customers. In fact, in this conference, by now I must have had 15 or so customer meetings. People often ask me, do I go SQL or do I go NoSQL? Do I have to manage my own database or can I get a fully managed application? Do I pay low cost? Unfortunately, high cost option is not available on AWS. We'll go with low cost. Now that we made that clear, for example, if you were to choose SQL choice, we can talk about what kind of reasons why you would choose that. MySQL is a popular choice among developers because it was embedded as part of the LAMP stack and people are very comfortable with it. Oracle and SQL Server are very popular among enterprise developers because they started with an IT application orientation. MariaDB is coming up real fast in the overall Linux ecosystem. We've also heard in the past about columnar databases like a Vertica or a Paraxel. You could do it yourself, all of them on EC2. You could also have a choice of using them on a managed basis from Amazon. We provide RDS, which gives you MySQL, Oracle, and SQL Server. Redshift, which gives you petabyte scale data warehouse on a managed basis. These are the choices. Again, we'll talk about why would you choose one path, which is SQL on your own versus SQL on a managed basis. You could also look at the other factor. Would you choose, under what factors would you choose NoSQL? If you do, which one of these engines will you choose? MongoDB, great choice for certain class of applications. Cassandra, Redis, Memcache. We try to make these choices available to you so that you can pick the right tool for the right job. We also provide for those application developers who choose to offload some of the management burden of installing, managing, configuring, and scaling to Amazon. DynamoDB is a great choice. We recently introduced Elastic Cache, including Redis, that allows you to run in-memory operations on a clustered basis. So the first set of questions that we hear from customers are, what are the right questions? People often ask me, should I use NoSQL or SQL? Should I use MySQL or PostgreSQL? Should I use MongoDB, Cassandra, or DynamoDB? What occurs to us, and in the dialogue that we think about and we have with our customers is, those are actually second or third order questions. The right set of questions may be, what are my scale needs? What are the latency requirements? How quickly do I want my application to be performing? What are my transactional and consistency needs? Do I need a transactional model that has multiple tables that needs to be joined and data needs to be maintained consistently across or not? What are my read, write, and storage and IOPS needs? Again, these sound technical, but rather than thinking about it at the what database do I choose, if you think about it from a bottoms-up perspective, you actually arrive at pretty interesting conclusions that helps your application come together faster, scale better. You can also think about how much control do you want to have from a database management perspective versus what are your time to market requirements. If you want to be innovating fast versus managing databases, those are the kind of questions you ought to be evaluating. Here are a set of ways to think about it. On the application side, you can start thinking about, is my application a complex application? For example, later you'll hear Sugar CRM, one of the leading world's open source database application for managing excellent customer relationship. Those of you who have customers, it's a good idea to maintain a good customer relationship, and Sugar CRM does a terrific job. That application is a highly transactional application. Will the app require lots of users? Does it require complex joins and updates? Who wants to be managing that database? Is it architected by the developer in terms of failover and other behavior? Or is that offloadable? Those are key questions that you would have to ask. Later, you will hear from Mike from Scopely, where there are parts of the application Mike's team has judiciously chosen to use NoSQL approach versus parts of the application where they've chosen to use transactional approach. Again, the idea of on-demand scaling is appealing to them. They are building a mobile application and a platform where that matters a lot, and that drives them to use a set of architectural choices. I'll let him explain that. What's important to realize is it's not an either-or. So you are not picking a direction of going left or going right. It's a direction of picking the right tool for the right job so that you can use best of both worlds. NoSQL and SQL can coexist. In fact, in most of Amazon's internal applications, for particularly front-end user-facing parts, we use a high-velocity, high-scale NoSQL store like a DynamoDB. And then as the information progresses through the cycle, when it becomes a confirmed order or something that we need to maintain relationship across multiple entities, they become transactional in nature, and therefore they become relational. So you can start to think about it along those lines as well. Another key questions I get asked all the time, why should I think about fully managed versus self-managed? Lots of reasons as to why you would want to pick one. Particularly self-managed gives you a lot of control. You will get access to the box. You could be running multiple things on the same box. You are responsible for your own upgrade cycle. In the enterprise sector, this is very common, where the IT organization typically thinks about controlling the overall update behavior. What we have often found out is what works for agile startups can also work for agile enterprises, where people can focus on, and this morning you heard from Suncorp CIO talk about it, where they are offloading all this infrastructure administration parts and having plenty of time to focus on their customers and be able to invent and simplify their life. That's a way to think about differently. That's the reason to think about managed service. The other part is when customers thought about self-managed and fully managed, they think of databases as sacrosanct entities where only a select few can touch. Whereas in a managed service model, databases are just a click away or an API call away. So you can actually design applications that are self-healing and self-managing. They do backups on their own. They restore when there is a failure. So it's about providing humans more time to lend themselves to creative jobs than simple administrative jobs. Probably one of the most understated benefit that I would argue in favor of going with a managed service approach is the pace of innovation. If you think about the RDS team, this year alone, so far we have launched 23 features and a couple of more to go. In fact, a couple of big announcements tomorrow will happen. Later, we'll also announce more features. NoSQL team, particularly the DynamoDB Elastic Cache team, has done a bunch of work related to launching features, particularly around Redis engine, fine-grained access control, and so on. Redshift team has been on a blistering pace. I think this year they released close to 40 features, 20 of them are significant. This is not available to you when you try to do these things on your own, because a lot of these features are coming in a managed service environment because it's easy to provide them, upgrade them, and so on. So those of you who don't know RDS, since only a subset of you who are raising your hands, let me just make a quick point. What is RDS? RDS is a fully managed SQL database service. It provides you a list of database engines. Today, we provide MySQL, Oracle, and SQL Server. Tomorrow, that may change, but today we provide those three. It's simple to deploy and easy to scale, and it makes you focus on your application. It's reliable, cost-effective. I think our smallest instance class starts around a penny or two pennies per hour. So you can really get going on building a highly reliable, highly scalable application infrastructure on fraction of a dollar kind of thing. All of that without any operational burden. So you are offloading installation, management, backup, recovery, failover, all of that to a service so that you can focus on managing the data. What are you really offloading? You're offloading all the things that I said on the right-hand side: migration, backup and recovery, software upgrades, storage upgrades. Storage upgrade in RDS is an online operation. So you can start with a 10 gigabyte storage drive. As your business scales, as your application grows, as you accumulate users, as you get more customers, more revenue, you can go all the way up to 3 terabytes per database instance. You can stitch together 10 or 20 of those and get a system that has 30 or 60 terabytes of data. That's pretty powerful. If you think about it, 60 terabytes is a lot of data. You can also focus on your application because we deal with all the hardware crash and network failure and other things. We can do an automated failover. What that means is you get to focus a lot more time on the left. You can design intelligent schemas. You can construct queries that serve your applications really fast. You can optimize your queries with the right indices. That's where your value add is, not on the right-hand side, we would argue. So I'm answering a question. The question was, did I say 60 terabytes? On a per instance basis, it's 3 terabytes per instance, but you can partition the data in the right way so that you can have 20 such databases. Of course, you are managing the partitions on your own, but we have seen customers use that technique to scale really well. Here's one important thing. On the right-hand side, I show you a picture, and this is really from the MySQL manual for creating read replica. I counted and I tried this on my own. There are about 75 steps that you have to go through to create a simple thing called a read replica. And later you will actually see our customers speak about it. Literally, it's a single button on the console or a single call. Create read replica, done, and it'll keep in sync. If you don't like it, delete it. So it's just very, very easy. Same is true with setting up a primary and a secondary and establishing a failover mechanism. That could take you literally 100 plus steps. And if you get one of them wrong, that things won't work. Here, that's a checkbox on a database instance that says, make this a highly available system. While you do all of that, you get a lot of database performance. You can augment the database, and you'll hear this from Mike, with a service called Elastic Cache. What is Elastic Cache? Elastic Cache is a managed caching service. A lot of times, your read queries for your application can be served out of a cache that is intelligently managed, as opposed to just straight hitting that select query over to the database. That way, your master database is free to take on more writes than your caching. Today, we support two major engines. We support memcached, which works very well with MySQL, and we also support Redis, so you can manage your cache clusters. Because the data is served out of memory, you will get ultra-fast response time. Even with SSD drives, you'll typically get a millisecond latency, whereas from memory, you're getting microsecond latencies. So your application would be really, really fast. It's a performance booster. As I said, you can set it up in such a way that your read queries are served out of a cache that you are managing at the application level, and then your write queries and some of the select queries are going to your MySQL or other database instance. So those are choices on the SQL side. You've often heard about DynamoDB. What is DynamoDB? In very simple terms, I'm happy to explain as detailed as I can during the Q&A. DynamoDB is a managed SQL, NoSQL database service. It's designed to be practically limitless in terms of both I/O throughput as well as your storage. You can store and retrieve any amount of data. You can scale throughput to millions of I/O. DynamoDB starts with the principle that scale is the database's problem, not the customer's problem. So you ask for more I/O, we'll give you more I/O. You don't need the I/O, you can turn it down. In fact, a couple of years ago, when DynamoDB was launched, one of the popular audio applications, Shazam, they wanted to launch a Super Bowl promotion. Literally 3 days before they called us, we turned them on, they launched the application, they went all the way up to a few 100,000 plus I/O throughput during the Super Bowl time. At the end of the game over, one of the engineers from our team called them and said, hey, you still have all of this, Super Bowl is over, and they turned it back down. That's the flexibility, that's the scale, that's the on-demand application that you get with something like DynamoDB. It's designed to optimize developer productivity. Literally, the entire API is right in front of you. So you can create table, update table, delete table. You can query or scan. You can get or put items, or you can do batch operations. There are a couple of more APIs being added, but you can see it's not as complicated. So if you're familiar with select, insert, update, you have APIs to that. If you're used to getting file output, you have options for that. So it's a very simple, straightforward model. It's fairly straightforward for application developers to go from SQL to NoSQL. The last one I would highlight is from managed services perspective is Redshift is a managed data warehouse service. It's built from the ground up to give you scalability starting with a terabyte all the way up to a petabyte. You can go from one node all the way to 100 nodes in a cluster. It gives you 10x the response time typically of typical relational stores. And it's provided for under $1,000 per terabyte per year. All of that without any operational burden. Those are some choices available to you. With all of that stated, the question in your minds are likely to be, what are the tips and techniques? How do I succeed? What's the right model for my application? While I provided the overview, probably the best thing for me to do is to have you hear from our customers. Let me invite to the stage from Sugar CRM, Zac-Sprackett, VP of Operations. Zach?
Thanks, Sundar. So, as Sundar mentioned, my name is Zac-Sprackett. I'm Vice President of Operations at Sugar CRM, and my team is responsible for our cloud strategy and all of our customer-facing hosting solutions. Just before I get started, maybe we could do a quick show of hands. How many of you are familiar with customer relationship management software? Ah, good number. And how many of you consider yourself to be salespeople? Nobody. Oh, sorry, one hand in the back went up. Okay. So how many of you, over the course of your daily business, actually end up communicating with your customers? A much, much higher number of hands just went up. We kind of live in a different world today than we did maybe 10 years ago, right? With things like Twitter, things like LinkedIn, you're much more connected to your customer base than you were once before. And it's now possible for your customers to actually reach into your organization and connect directly with engineering and other groups that were traditionally black boxes, right? I'm on the operations team, but 3, 4, 5 times a week, I get parachuted into calls where I'm talking to customers about scalability, about reliability, about durability, about all of the things that we do to help them to be able to, all of the things that we do to help them to be able to be successful with our product. So if we're in a new world where every one of us is effectively a salesperson and we're all talking directly to customers, why are CRM companies still focusing on building a tool for pipeline management, right? That's sort of a really tiny, tiny piece of the customer relationship management puzzle. So at Sugar, we're actually looking to redefine the CRM space. And we're looking to build a product that focuses directly on the user of the system and ensures that the data that you're putting into your CRM is useful and accurate and available to you all the time. And we're looking to increase the market for CRM software substantially by exposing it to all of these different groups that wouldn't traditionally have used CRM in the past. And we've been very successful with this model. In conjunction with this sort of repositioning of the CRM space, we're also looking to provide a really unique product bundle for our customers. We have both on-premise and hosted offerings. My team is responsible for managing the hosted offerings. We're a company with open source roots, so we offer our customers full access to their SQL data, full access to their source code. They have the ability to move back and forth between the different product hosting offerings that we have. And we have built a product that really scales, right? So we have customers that start with a single seat, and we have customers that go into the tens of thousands of seats. And we really wanted to be able to provide them with sort of different options that met their needs depending on the size of that customer base. And one other thing that's sort of interesting about us is our customers are distributed around the world, right? And every one of those customers in every one of those regions and every one of those different sizes, they all have slightly different requirements. Compliance requirements, internal requirements, requirements for their customers. It really is different from one customer to the next, and it's hard to build sort of a one-size-fits-all solution. So we've started from the ground up trying to build something that was very flexible and to be able to work with all of those different kinds of customers. So I'll talk a little bit about deployment models. If you think of a traditional SaaS model, think of an application like Gmail, for example, right? It's a single code base. When Google decides to do updates to Gmail, they push out updates to that code base. All of the customers just get it. You don't really get a chance to opt in, opt out. You're kind of at the mercy of the SaaS provider in terms of when you take things. Oftentimes, there's not a lot of ability to migrate back and forth. So if you want to take your data, you want to bring it home, you want to go play in some other sandbox, for example, that's not necessarily an option for you in a traditional SaaS world. At Sugar, we do things very differently. As I mentioned, our application is designed from the ground up to be something that you can deploy on your site. It's designed also to be something that we can host for you. And it's designed in such a way that we can do that in a multi-tenant environment. We can do that in a single-tenant environment. And we really have the complete flexibility to offer you whatever kind of hosting freedom you need. So our application stack is actually pretty simple. It's a typical LAMP application. So we use, obviously, Apache as our web server, PHP, and we have a custom layer inside of PHP called Shadow that allows us to deploy a single code base and have that code base shared by multiple customers. But Shadow also has some additional flexibility in that it allows our customers to be able to upload deltas from that shared file system, right? So if you want to override something, you want to customize something, you have the ability to do that and just store those deltas. So it saves us from having to store multiple copies of the same environment over and over and over again. We're Linux underneath. On the back end, we talk to a MySQL database. We do all of our data that's in the relational database. We full text index it in Elasticsearch, and we use cron for running background jobs. On the client side, we're looking at a traditional or a typical HTML5 JavaScript application delivered to the browser, delivered to the mobile device, and we're using traditional protocols like HTTPS, we're using REST, we're using SMTP to get all of your data into your CRM system. So the application stack itself is really, really quite simple. So how do we do it? How do we do it inside of Amazon? How do we build something with a simple application stack like that to be able to support all of these different customers and all of their different deployment models? Well, we start with the concept of cloud stacks. So we build these cloud stacks ourselves, and each one of these cloud stacks can support a single or multiple customers, depending on what arrangement they've signed up for. So our cloud stacks are built to span multiple availability zones inside of Amazon in a particular region. Our cloud stacks are made up of EC2 web servers deployed in each one of the availability zones. We also use EC2 servers for running our job servers, and EC2 servers just running Elasticsearch. On the back end, all of our data is relational, so we store it in a multi-AZ MySQL RDS, and we use Elasticache, the Memcache version of Elasticache, for doing our session storage. So as you can see, we've built our cloud stacks to be very fault tolerant. On the back end, we do backups outside of what's available just with RDS into S3 so that we have individual backups that we can hand to our customers. They can download, they can store it in their own secure facilities, and they know that their data is safe and that they have a copy of it. And then obviously we do long-term storage on top of Amazon Glacier. So in front of these cloud stacks, we have what we call cloud providers. And cloud providers, once again, are designed in such a way that they can support a single cloud stack or they can support multiple cloud stacks. And so cloud provider for us is really DNS managed by Route 53. We use a managed elastic IP address that we float back and forth ourselves in between the HA proxy servers that we run. We had some challenges that kept us from being able to use ELB, so we ended up using HA proxy that we built ourselves, and it's working quite well for us. And so to manage all of that, we built our own custom management console. We did that using Ruby on Rails and Fog, and that allows us to leverage all of the Amazon APIs to be able to spin up cloud stacks and cloud providers. We also tie in directly to the operating system on those hosts and can spin up customers in different configurations, can perform all of the maintenance tasks that would typically have to happen, such as delivering customer backups, importing new customers, exporting customers, all of that kind of stuff, all from a centrally managed environment. So we built this ourselves. So what are some of the things that we learned along the way? Obviously, Amazon makes it really, really easy to test things, right? It gives you a lot of flexibility that you didn't have previously. I come from an environment where we are a company who had a data center. We had multiple data centers. We hosted all of our customers there. So we were really accustomed to sort of the hardware purchase order process. We had a lot of experience dealing with that. But that sort of cycle makes it really difficult to be able to do things like effective testing. Amazon makes it really easy to spin up copies of your production environment. You could take a snapshot of your RDS database, you could spin it up, and you can do actual testing with your production data, not with a production-like environment. Really, really simple. Obviously, while you're doing your testing, you want to be monitoring everything so that you can be aware of any sort of problems that you're going to experience before your software ever hits production. So one of the things that was sort of challenging about this is that it changed our cost model, right? Our finance department was really comfortable with the whole hardware purchase order cycle because we would sit down and 6 months in advance, we would say, you know what, this next year we're going to go out, we're going to spend this much money. We have this many customers. This is what we predict our growth is going to look like for this next year. And so then we would come to this conclusion that, hey, this is how much money that we need to spend for the coming year. And every time I went to purchase hardware, I would put it against one of those existing purchase orders, and I would always be working within my budget, and they would know in advance if I was going to go over it. That changes a little bit with Amazon, right? You have the ability to spin things up, and you're paying for them after you've used them, which causes a little bit of pain with your finance department as you're going through this process and you're trying to put controls around it. So it was important for us to have those conversations with finance early and get them to understand that there was going to be a change in how we were going to be making use of hardware, how things were going to be built, and that, some of the things were going to be slightly different. And so we came up with rules of engagement that made sense for us before we got into problems. Another thing that really was sort of interesting for us is, like I said, Amazon makes it super, super easy to spin up test instances. It makes it super easy to spin up development environments. So when we started doing it, people got hooked, right? Our QA department loved it. Our engineering department loved it. And we kind of made it into a free-for-all initially, right? We were handing out access keys to people all over the place, and they were spinning up and doing their testing on infrastructure, and then they were kind of walking away from it. And they wouldn't think of the steps afterwards of tearing it down. So it was really important for us to sort of step back and realize that, okay, maybe even though we want to be able to provide these capabilities to everybody, maybe there should be limited numbers of points within the company when you can actually spin up new infrastructure, or people who have responsibilities for these kinds of things. So we've learned to make effective use of IAM to make sure that people have access to spin up things, and we are able to effectively stay within our budgets. We also love tools like Cloudability that help to give us a checkpoint along the way of how we're doing against our budget process. So what are some of the things that you need to watch out for? As Sundar mentioned, understanding your application is really, really important as you move to cloud. Your systems are going to behave slightly differently than the hardware that maybe you have in your data center today. So understanding where your bottlenecks are in your application allows you to effectively mitigate those kinds of things. And Amazon provides a lot of tools to help with that, right? Things like provisioned IAPS, things like SSD-backed storage, all kinds of things are available there for you to take advantage of if you know how your application performs. So monitoring, understanding where your bottlenecks are, and then constantly working to improve those. Read replicas are amazing. I use these all the time. I spin them up. I do CEO-type queries against them, right? The random stuff that's going to take a long time to query, and then I tear it down at the end of the day, and we don't have to pay for it going forward, right? My team was responsible for doing all of this stuff in the data center. We had people who were dedicated to replicating data, building up new machines, making sure that MySQL was synced. So those people have been freed up, and they can now work on things that actually matter to our core business, right? Improving the product, improving the customer experience. So that's been a great deal for us. Another thing that's important to understand is as you're building a business continuity plan, cold standby doesn't necessarily mean instant on, right? So if you've got a second availability zone, and you need to actually, or a second region even, and you need to spin up all of your instances in the event of some sort of catastrophic failure or whatever, you're going to be waiting in a queue with everybody else who's experiencing a similar kind of failure. So it's important that you build out your disaster recovery plans, your business continuity plans to understand that in your worst case, in something like the cloud, there's a chance that you're not the only person who's experiencing their worst case, and plan for that kind of event. Right? We also like to keep backups of our data outside of Amazon for an even worst case, right? You just need to be able to sort of understand how to plan this stuff out and really think about what are the potential situations that you can run into. Another thing that's important to understand is to watch out for the SLA, right? Amazon offers a 99.95% SLA for a region. Now, so in my environment, I deploy across multiple availability zones. But the SLA to me doesn't actually go up, right? I still have the same 99.95% SLA from Amazon. The only thing that actually goes up with a deployment like that is my confidence, right? Because I now have some ability to do failovers. And obviously the Amazon SLA doesn't include any sort of user error or problems that you cause. So plan for that as well. Obviously you still need DBAs, you still need ops people, but the cloud really allows you to have those people focus on the things that matter to your business. And finally, it would be absolutely horrible if I didn't tell you that we were hiring ops people, we're hiring dev people, we're hiring sales people, we're hiring across the board. We just announced 80% growth year over year last year, and so we need additional people to come and join the team, come work with me, and help to make Sugar a better product and get it into the hands of more people. And we do have free trials available, so give it a try. Try it out yourself.
Thanks, Zach. Now it's my pleasure to invite to the stage Mike Scopely. Mike Scopely. Mike from Scopely. Thank you.
Thank you. Thank you. Like you said, my name is Michael Thomas, and I'm the principal platform engineer from Scopely. We're a mobile gaming platform company, so our goal is to build technical infrastructure that allows developers to build games efficiently for both iOS and Android. We've been pretty successful with that, launching 5 top games. The last 3 have been #1 in the App Store. Millions of users playing them with billions of turns every month. So some of the challenges that we face building this is we're building a single platform that supports a wide variety of different kinds of games. Asynchronous games, single-player games, in the future, synchronous games. In addition to that, one thing that's really helpful with Amazon is that we add new games frequently, scale games up. We acquire new users for games. We test games, and we retire games eventually. So our use of the platform increases and decreases over time. And most importantly, we're not an infrastructure company. The value that we provide isn't by building infrastructure out, it's by building features that make it easier to build games. So our platform has a huge variety of features. I'm not going to read them all, but this just gives you a little idea of what they are. You know, user accounts and authentication, chat, game state management, statistics, A/B testing for your gameplay, all sorts of stuff. And each one of these features has different requirements to it. So some have the need for dynamic scaling. You know, when we're launching games, when we're doing promotions, when we're doing tests, we may get a huge influx of users into one specific game or multiple games. Other aspects of the platform have a very high write-to-read ratio. So when people are playing turns, that we're actually like writing more than we're reading from a given data store, which is counter to the normal use case for relational databases. Other parts need high transactional consistency. People are making real money purchases in the games that are on our platform. Other things are indexed. User accounts, we have to be able to search for people by username or by some social network that they're associated with, by email address, that sort of stuff. And finally, there's some complex real-time data processing to handle leaderboards and tournaments and other things like that. I'm going to focus on our operational data storage in this talk, rather than the whole application layer. But our gaming platform is built on top of several different data stores. First, we put Elasticache in front of everything. This is the Memcache version of Elasticache. And because of its high performance, it provides value to be on top of DynamoDB, on top of RDS, on top of anything that we're storing data in. We use DynamoDB for anything that's going to be an unbounded data set, right? So if this data set's going to just keep growing over time, for example, all the turns someone's played, or all the items someone's used in a game, all the people, all the things someone's purchased in a game, it'll go into DynamoDB, so we don't have to worry about that data growing over time. For things that require transactional consistency, we put it into RDS. Elasticache in the Redis form is used for some really specific use cases that I'm going to talk about later. It provides some really special features that allow you to do things that other data stores really don't even make possible. Finally, we use S3 for asset and image storage and other blob storage. In addition to our operational data store, I'm not going to go into as much depth on this, but we have an analytical data pipeline for handling offline, semi-real-time analytics. Similar to our operational data platform, we use a variety of different data stores to make this possible. We first capture in-flight events from our platform. So every time someone plays a turn or makes a move, purchases something, logs in, opens an app, it gets sent to SQS immediately and queued up there. The nice thing about SQS is it's extremely reliable and very available. So even if our platform is having some downtime or there's a capacity issue, SQS can absorb those peaks of traffic. We We have a cluster of EC2 machines loading those SQS messages into a staging bucket in S3, and then we use Elastic MapReduce to transform that data, which is like complex JSON objects representing those actions that have happened, into the schema in a format that can be loaded into our data warehouse. So we use Redshift as the data warehouse and have another cluster of EC2 machines to bulk load that into Redshift. The cool thing about EMR is that we can use a framework called Mr. Job that allows us to use Python to define a schema mapping. I'm not sure how well you can see this, but basically this is a way that you can extract like complex nested objects out into a flat format that goes into a data warehouse more efficiently. So I want to talk through specifically a few use cases and why we chose different data stores for those different use cases. So one of the things we do is leaderboards. Leaderboards are like, here's all the people who've played in this game and what scores they've got today or this month or this week, or even here's all your friends. And there could be hundreds of thousands or a million people on a leaderboard. And it's a rather hard thing to do computationally, and it's very hard to cache because if one person gets a new high score, the rank of everyone below them changes. And the most common question is, what's my current rank? So we initially had that in RDS database. We optimized it, did some algorithmic stuff to make that as efficient as possible. And we were using read replicas, as was recommended. And it was still taking over 100 milliseconds to find someone's rank, since it has to scan through that table or do a binary search on the table to find where you are and what your rank is. By using Redis in Elasticache, they have a data store called a sorted set that does this exact thing for you. And this reduced the time to take this query from 100 milliseconds down to like 1 to 2 milliseconds. And beyond that, rather than having to have 4 large RDS instances, we can do this all on a single Redis instance with vastly simpler code in addition. Another data store we do use extensively is DynamoDB. So the great thing about DynamoDB is it can handle extremely high throughput. Like I said earlier, basically infinite amount of throughput. You can write as fast to it as you want and read as fast to it as you want. And you can handle extremely large data sets. We have multiple terabyte data sets in there already. The data is semi-structured, which works extremely well for storing the state of a game. So like this is where I am in a level, or if it's a checkers game, for example, what's the state of that board. And each different game that our platform supports has a different structure of that game state. So Dynamo's semi-structured data is extremely effective for this. In addition, because we're always querying game state by either what game is this or what user's game this is, Dynamo's lack of indexes isn't an issue at all. We'd initially done this storage on RDS, maxed out the largest RDS instance that we could find at the time, or could use at the time. This is before they introduced the CR1 cluster compute RDS instances, and migrated to DynamoDB. And we're actually saving money because of that, and it saved us having to introduce extra application logic to do partitioning at the RDS level. Now we just store in one Dynamo collection, and as our users, as our games grow, or the number of turns grow, we just increase the capacity of that one Dynamo collection, and we don't have to worry about anything beyond that. Another thing is RDS, which is extremely useful for a lot of things. So I talked about we use it for transactional things. So we're tracking actual real money purchases that need to be, make sure we only credit those once, make sure we have a ledger of that, goes into RDS. In addition, we use it for user accounts, right? Because when we're looking up user accounts, we can need to look up by username, by email address, by social network ID potentially, and it's a fairly bounded data set. No matter how large our platform is, there's a finite number of users we're going to have, 6 billion or so, everyone on the planet, best case. RDS is going to be able to handle that. And plus, another nice thing about RDS is that it handles like large table scans and big data exports very efficiently. Whereas DynamoDB is more for random access. RDS, we need to do a huge scan of all your users for a promotion or for some targeting thing. Has some more optimizations there that you can do. And like I mentioned earlier, Elasticache is fantastic for global caching. We put it on top of, like I said, everything that we do is a global central cache. Now, the con of Elasticache, Memcache, is that it evicts data, right? It can never be your final source of truth, but that's inherent in its nature, so it's not really a con. One of the things we've done to make this easier for our developers and make the use of it more consistent is create a code-level interface that makes caching pretty transparent. And it looks something like this. We call it coherent storage since it keeps everything consistent. But it layers different caches and then layers a final source of truth underneath. So we'll use this for Dynamo, we use this for RDS, but the interface for the application developer is the same. Save this object, get this object. Handles caching at the session level, handles the caching in Elasticache, handles hydrating the object from DynamoDB if necessary. Finally, I just want to talk through a few tips and traps that we've noticed or found to be helpful for being able to develop this application rapidly. So one of the main goals we have is to be able to release new features quickly without any downtime and with minimal operational overhead. Going back to the beginning, we're not making value by building fancy operational systems. You need to know the data that you're trying to store. And it's good to set up some sort of heuristics for where you should store a certain type of data. So one of the rules that we have is this data point going to be larger than the number of users that we have? If it's going to be larger than the number of users or has the potential of being larger than the number of users, probably a good idea to put it in DynamoDB so that you don't have to worry about scaling or partitioning it in the future if it becomes even larger than you expected. But if some data point is inherently smaller than the number of users you have, it's safe to store in RDS because it's a bounded data set and you don't have to worry about scaling too much. Now, the RDS doesn't scale, but in terms of avoiding that extra operational overhead of partitioning data, Dynamo gives you that advantage. Another thing we've noticed is that it's good to have a tool belt of data stores. Rather than trying out every single data store under the sun, we've picked a few ones that work really well for us. RDS, Redis, DynamoDB, Elasticache. And Redshift in analytics. Between those 5 data stores, we can handle most situations without introducing the operational overhead of managing a different type of data store. Something else we've been experimenting a lot with is getting really creative with DynamoDB. We can talk about this probably more in other sessions or in a Q&A, but Dynamo is basically a key value store at some level. But there are ways to use indexes on it or use the hash keys on it, use local secondary indexes, and using sparse local secondary indexes to provide much more sophisticated querying options than you would expect otherwise. And finally, this may seem like a really trivial, simple thing, but one of the things, again, we want to be able to add features quickly without downtime. And one thing we do is add a metadata column to most of our MySQL tables. And this is as simple as if you have a table that's, for example, a list of products. At the end of the table, put a column called metadata that's text. So in the future, if you have some additional data that you want to store with that product, you can do it without doing a schema migration. There are ways to do online schema migrations with RDS, read slave, do the schema migration there and fail over to that, but that's operational overhead. Much easier to have that prepared in the future or prepared in advance so that you can just build those application features without worrying about the data store itself.
Awesome. So both Zach and Mike did a much better job than what I could have done. So that's awesome. So at this point, we'd open it up for questions. Any question, all questions are valid. Please feel free to come over to the mic. I would like to invite Mike and Zach because they probably have more practical answers than whatever I can think of. Go ahead, sir.
I noticed the conspicuous absence of SimpleDB on some of the slides at the keynote this morning. And it seems to be kind of going away, but I saw it on your slides. So I was wondering, what's the status of SimpleDB? Because it seems to overlap a whole lot with DynamoDB.
So great question. So maybe I'll take this one. The question is about SimpleDB. So as we continue to evolve our technologies, we find that sometimes what we did in version 1 requires an evolution. SimpleDB will continue to exist, but we think DynamoDB provides a much better interface and much better throughput model than SimpleDB. So Amazon is the kind of company where we don't make very easy decisions on what comes in or what goes out. So SimpleDB will continue to operate. However, I would probably encourage you to think about DynamoDB as a useful choice or other data stores too. Yeah. Second question.
Any plan to add a multi-AZ support for SQL Server on RDS?
A great question. So once again, it's a question for me. The short answer is yes, we are working on it. I just can't give you a timeline yet, but you should expect that soon, in the Amazon timeframe of soon, not the other vendor timeframe of soon.
Hi, my question's for Mike. I
Mike.
noticed that you were using two different caching solutions, and I was just wondering why both Memcached and Redis?
Yes, so the question is, why do we use both Memcached and Redis? We use Memcached because it's been around longer, actually, and it's a very consistent interface that supports, or that's supported by every language. And it's also extremely simple. It's key value store, extremely fast, extremely reliable. Redis provides some features that Memcached does not provide. Sorted sets, is in particular, timed expiration, persistent stuff that will never be evicted. Theoretically, you could replace Memcached with Redis in most cases, but when we implemented this platform in the first place, there was not a hosted Redis solution.
So what are you using for your very write-heavy loads? You mentioned that earlier.
Question from you?
Yeah.
Yeah, for write-heavy loads, we find DynamoDB to be the best option because you can scale the write and read capacity independently. And the write capacity can be scaled unbounded.
Do you have plan to support Postgres in RDS?
So I think that's a question for me. Good question. So I think definitely attend the Werner's keynote tomorrow.
Yes. So my question is, you talked about sharding, 26 ways with RDS. So if you're going to shard with RDS, is there a way to take consistent snapshots or backups across all shards without stopping the application for a short period of time?
So have either one of you tried sharded design pattern?
We shard at the database level, not at the in the individual customer database level.
Gotcha.
Not inside of a
So
database.
So you're saying that consistency of the backups isn't so important for you. Is that right?
For us?
Yeah, consistency across the shard thing.
Yeah, we shard individual customers, so.
So, I mean, is there an answer to this? So if consistency
I'm
across the shard.
trying to make
is
sure
important-
that,
We don't do any RDS sharding, and instead of put our larger workloads onto DynamoDB.
right. So when you, inside the RDS engine, we don't provide sharding in a managed way. Therefore, the consistency of the sharded, backups of the shards will have to be done by the application because the application has the knowledge of where each resides. So you'll have to sort of cycle through and say, back it up, back it up, back it up, and get that across that way.
And so you basically have to shut down all writes for some period of time during which the backups are taken across all shards or the snapshots?
That depends on what you need consistent, how consistent you need your data, whether or not there needs to be consistency between the shards. In a lot of use cases, there doesn't actually need to be.
Right.
Right.
Since you're, it's a little bit of a complicated topic, I'll be happy to sit down and explain to you. But one thing is, your application is aware of what shards contain what data, and therefore you can selectively stop writes to the ones that you are taking backup. By the way, our backups are online operations. So you could be initiating a backup, and we'll do it behind the scenes. So you don't need to shut things down in order to take a backup. Our snapshot operations are online operations.
Okay. So you might just pause your application for like 1 second, initiate the snapshots across all 26 shards, and then
Correct.
that's it.
Yeah.
Basically.
Question for Zach, really around if you support schema differences for customers, if customers can go in and modify their own schema?
We do, and that obviously presents some very interesting challenges for us, right? Because every customer is adding custom fields into their CRM. They have different workloads. They integrate with different third-party things like CTI or whatever. So we do have a lot of variation from one customer to the next. We try and build our SQL intelligently using a query builder. That doesn't always work out. So we still need to have our DBAs go in and sometimes manually add indexes, look at queries that are causing us problems. And we lean really heavily on our monitoring software to be able to point out those hotspots so that we can get there early, we can make changes, and we can do things before really people feel the impact.
And is that supported then through your upgrade process, where then those changes as a new version of the base comes out that you can reapply those?
Absolutely, yes, absolutely. They get pulled forward, and obviously as we add them, we work with engineering to see if there's things that we can do to help further optimize our query builder so that in the future we don't run into those kinds of issues.
Okay. One last thing. Do you do anything from a multi-tenancy for throttling individual customers' access to the system?
So that is something that we do a little bit of, but for the most part, we sort of open that up, and customers have the ability to do what they need to do. In very, very extreme cases, we do have the ability to lock people down. Sometimes we see people go crazy on the APIs in a multi-tenant clustered environment. In those cases, what we would do is we would typically rate limit the application and offer the customer the ability to move into a private cloud resource that looks exactly the same to them externally, but provides greater capabilities and greater throughput for their needs.
Hi guys, thank you for the talk. My question is, what do you do about syncing data in your databases specifically across regions? If you'd like to keep it closer to real time, which I think you probably can't do, are you just dumping data backups across regions and restoring them in sort of pocketed time, or is there any tricks to getting it closer to real time?
In our case, we are just dumping backups and keeping those and using those for recovery. All of our customers are actually home to a specific region. So we do have points of presence in all of the different geographies where customers will be homed out of. And that allows them to meet their own compliance needs and all of those kinds of things, and to have, obviously, quick access to their customer instance. But in terms of backing up between regions, that's an offline thing that we do.
Well, not backup specifically, but say there's data, users need to interact with each other across regions. They may be home to a region. How do you get them to
That's
interact?
not something that we do today. So users are home to a specific region.
I do have an answer, but I wanted to see what Mike might have.
We similarly don't do that today. It's more of an application level logic. In our plans to do that, it would be an application level thing where you're duplicating things at an application level across regions.
I would also encourage you to go to Werner's talk tomorrow. I would say this, you are not alone. We have heard from many customers on how they want to operate cross-region for 2 or 3 different use cases. Primary one being quick disaster recovery. So the recovery point objective is not in hours. They want it to be in seconds, if not in minutes. The recovery time objective is also not in days. They want it to be very instantaneous. They want to be able to create a new instance, get up and running. That's one use case, and the other one is as users move, global users move from, say they live in San Francisco, went to New York, took a picture, and they are now conversing with their friends who live in New York using a mobile application. They want it to be geo-dispersed read queries to be properly updated and provided. We have thought through that. We are providing an initial option for MySQL, and so if you listen to Werner tomorrow, you'll have more questions, which you'll be happy to answer.
Thanks, guys.
So that's looks like that's all we have time for. Thank you so much for your time. I appreciate all your questions. I'll hang around here. Thank you.